what is quality? Now, see, the most popular definition of quality was coined by the quality guru, Philip Crosby, which is conformance to the requirements or conformance to the specification, right? This is most important definition of quality. This is most popular definition of quality, right? Coined by Phil Crosby, conformance, right, to the requirement of the customer. There are other definitions of the quality also. For example, coined by Joseph Juran. This is fitness for use, right? And you know, the PMI definition of quality is very close to Phil Crosby's definition of quality, which is the first one. Quality is the degree to which a set of inherent characteristics fulfills the requirement. Now, a question to all of you. If I say quality of a sedan car is better than hatchback car, or quality of a business class in an airplane is better than the economy class, have I made the right statements? If I say quality of hatchback car is inferior to sedan, or quality of economy class in an airplane is inferior to quality of business class. Now, are these two right statements? Are these two right statements, guys?
I think these are not right statements.
These are not right statements, right?
Yeah.
So what you want to say is, you know, so long as an economy class conforms to the specification laid out for it, right? Or so long as a business class conforms to the specification laid out for it, right? They both are good. They both are good, right? Similarly, as long as the hatchback car conforms to the specification laid out for it, it's a good car, right? Now, the difference is they are different grades, right? These are different grades of car, right? But the statements are incorrect, right? Now, what is a grade? Right? What is a grade, guys? Now, grade is a category or rank given to entities having same functional use but different technical characteristics, right? This is grade. Now, tell me, is low grade a problem or an issue? Is low grade a problem or an issue? Tell me, guys, is low grade a problem? Is low grade a problem, guys?
It depends, I think, like
may or may not be.
Yeah.
See, low grade is never a problem. See, if someone can't afford a BMW, he should be happy in Maruti.
Yeah, so if we are giving the bare minimum features, then it should not be a problem.
Right? See, you know, low grade is never a problem, right? If you can't afford a business class, right, you should be happy in economy, right? But is low quality a problem?
Yes.
Low quality is definitely a problem, right? Now, in the next slide, I'll show you some of the equations related to quality. These are 6 bulleted points. I hope you all will agree with these. Now, do you agree with the first point? Quality is equal to customer satisfaction is equal to business growth. Do you agree with the first bulleted point? Quality is equal to customer satisfaction is equal to business growth.
Yes.
Perfect, right? Now, obviously, you know, when this leads to repeat business and the business growth. Quality is equal to pride in delivery and high team morale. Right? If the team is delivering high quality deliverables, their morale also goes up. Right? Lack of quality means lot of rework, lot of returns, lot of recalls. So can I say lack of quality is equal to cost? Can I say lack of quality is equal to cost, guys? right? So lack of quality is loss of customer confidence. Lack of quality is equal to loss of reputation and difficulty in gaining new business. And the last one is lack of quality could lead to loss of life. Will lack of quality lead to loss of life?
Yes.
Right? See, if you talk about airplane, healthcare industry, lack of quality could lead to loss of life also, right? Now, one general statement, right? This is a basic quality principle, and it has been addressed in many of the frameworks and methodologies. Like we learn Lean, we learn Kanban. All were talking about this. In fact, entire Agile was talking about this. See, in quality, prevention should be your focus should be prevention as compared to inspection, right? The focus should be prevention. Don't think about quality only from the perspective of testing, right? You should focus a lot on process improvement, audits, right? Doing the work right way, right? In fact, one of the code that describes this is quality should be planned in, not inspected in, right? Quality should be built in. It should be, right? It should not be inspected in. Quality should be integrated throughout the project life cycle, right? Now, a very important concept which is called as cost of quality. Now, this is an important concept. What is cost of quality? Now, cost of quality has two components, cost of good quality and cost of poor quality. Cost of good quality is cost of conformance, right? This is cost of conformance, right? You can say good quality or conformance. Now, see, in projects, you spend money or you spend efforts in inspection, testing, reviews, right? This is cost of good quality, right? It comes under appraisal cost, right? It is appraisal cost or cost of good quality. Similarly, in project, you spend a lot of money in prevention, right? Like process improvement or activities, training, right? Mentoring, coaching, right? A lot of defect prevention activity. This is cost of good quality. So is the difference between cost of good quality and cost of bad quality clear? Sorry, cost of good quality. Do you understand cost of good quality now properly? Cost of good quality will include appraisal cost, right? When I say appraisal cost, it is primarily inspection, reviews, testing, right? Product audits and compliance activity. Whereas prevention costs are more like training, mentoring, coaching, tool evaluation and automation, right? Hardware and software upgrades, defect prevention, right? So this is cost of good quality, right? Now, what is cost of bad quality or cost of poor quality? Cost of poor quality is also called as cost of non-conformance, right? Any kind of internally detected bugs, right? Any kind of internally detected bugs is, right? Internal failure cost is cost of poor quality. Any kind of bugs detected by a customer are external failure cost. So, cost of non-conformance or cost of poor quality. It includes both internal failure cost and external failure cost, right? For example, in any kind of returns, recalls, they come under external failure cost, right? Now, we have learned two things, cost of good quality. Tell me, what is another name for cost of good quality? What is another name for cost of good quality? Cost of conformance, right? This is cost of conformance, right? This is cost of non-conformance, right? Now, tell me one thing, if I spend a lot of money or a lot of effort in cost of good quality, my cost of poor quality will go down. If I spend a lot of efforts in cost of good quality, will my cost of bad quality go down?
Yes, it may.
Right? But is it worth it? Is it worth it? Now, we'll learn it through an economic conformance, right? Level graph. Right? Let's try to understand this in more details. Now, this is an economic conformance model. This is economic conformance model, guys. Now, in the economic conformance model, the y-axis is the cost, the y-axis is the cost, and the x-axis is the time. This is time and this is cost. Now, did you notice one thing? See, as I am putting more and more money in cost of conformance, this is cost of conformance, right? Which is prevention and appraisal. As I am putting more and more money in cost of conformance, the cost of non-conformance is decreasing, right? And the total cost take the shape of a parabola like this, right? With vertex, this vertex at economic conformance level. With vertex at economic conformance level. Now tell me, at what level should we have when we think about cost of quality? At what should be our cost of quality, right? How much cost should a company spend in conformance? What is the right level or optimal level of cost of quality? What is the optimum level of cost of quality, guys?
ECL.
Okay. Now see. Now Vishal says ECL. Do you all agree with ECL? Vishal says ECL. Do you all agree with ECL? What do you think? Anushri.
Not sure. Pankaj.
Okay. So tell me, should it be now? See, there are see what is your cost of quality? It also depends on your brand positioning strategy, right? Now, definitely, if a product is for masses, ECL is a best strategy. But tell me, if company only wants to target niche high income customer group, very niche high income customer group, if the company wants to target those, then in that case, what should
ECL?
Economic conformance level. तो इसका इंटरसेक्शन है, ये कॉस्ट ऑफ कंफॉर्मेंस है, सॉरी ये कॉस्ट ऑफ कंफॉर्मेंस है, ये नॉन कंफॉर्मेंस है, इनका सम जो है दैट इज ईसीएल, राइट? दिस इज ईसीएल
दोनों का ना?
हाँ, ये जो ईसीएल मतलब सबसे लोएस्ट पॉइंट, वर्टेक्स ऑफ दिस, ये पैराबोला है ना, का वर्टेक्स जो लोएस्ट पॉइंट है, ये ईसीएल है. So what I'm saying is, if a product is for masses, ECL, but tell me, if company wants to address only niche, very high income group, or right? So should they do ECL or should they do higher? What do you think, Vishal?
I mean, even if it is for a niche market, right, they would still want to control the costs of.
देखो control cost करना अलग बात है. Quality में, testing में कितना, देखो testing में, as you put more and more money in testing, right? More money in testing means more testing.
Correct.
Right? That is more better use of tools, so that defects are not escaped to the customer. Now, let me tell you one thing. See, if you buy a Honda City, right, a brand new Honda City, there is a minor defect, right? And they call you very softly, right? They will take your car, right? Fix the bug, right? Compensate you for a cab bill for some time, right? Till the time your car is not returned. And you may be slightly irritated, but you are okay finally. Yes or no?
Yes.
But tell me, if you buy a high-end BMW or Audi or Rolls-Royce, if the same thing happens, what will be your irritation level? Tell me, what is your irritation level?
Yeah, very high. Very high,
right? Now see, it's same. If you buy a very ordinary pen in less, of around 100 rupees or 50 rupees, right? If it blots or there is some problem, you're okay. But if you buy a Mont Blanc pen which costs you 50,000 rupees, if it start blotting, Will you be, can you tolerate that?
Okay,
No.
no. Yeah.
Yeah, see why? Because, these are the brands, they charge 12 times food, they charge huge premium on their product. They charge huge premium. Since they charge huge premium on their product, right, they can afford that level of profitability. So they can afford that level of money also to be spent in testing. Are you getting, are you following what I'm trying to say?
Yes.
So how much money you spend in quality, it also depends on your brand positioning strategy, right? All the companies may not be at ECL, right? Yes, in general, those companies who are catering to masses will be ECL. But if the company has decided that, they only want to target niche customers, right? Or very high income groups, right? They have to be somewhere, right? So this is in brief about cost of quality and economic conformance model, right? Now, what we are going to learn in quality management are these three things: planning quality, managing quality, and control quality. Now, see, I'm using PMI terms because, some of the questions are still being taken from the old question bank, right? So, all of a sudden, PMI started using a word manage quality. This started from project management body of knowledge, right? 6th edition. This is manage quality. Can you see manage quality? Plan quality, right? And control quality. Now, when I say plan quality, right, these are the three things that you will see in quality management: plan quality management, manage quality, and control quality. The first process is creation of the rules of the game, right? The process for managing the quality, right? For example, what tools you are going to use to manage quality, right? What data you will capture to manage quality, how the testing will happen, right? What all quality standards you are going to follow, what are the quality responsibilities different people will have. Anyways, this will be uh, written in a document called as quality management plan. Now, how does that document look? What does it contain? We'll see it shortly. This is one aspect, one important set of process or set of activities to be done in quality. Second is manage quality. Now, see, manage quality means, right? I'm just writing the meaning of it actually. Manage quality means two things, right? Manage quality means two things. I'm just putting an arrow here, right? This means two things. It includes quality assurance. Can you see what I'm writing? Quality assurance. Can you see quality assurance? Guys, can you see the screen?
Yes.
Yes, quality assurance plus continuous improvement. Right? This includes quality assurance plus continuous improvement. Is that okay? Quality assurance plus continuous improvement, right, is a part of managed quality. Is that okay? Is that okay, guys? Now, tell me one thing. We all know what is continuous improvement. Small improvement on constant basis, right? And this philosophy has been taken from Kaizen, and this has been embedded into Agile also, right? Now, tell me, what is the difference between quality assurance and quality control? This is an important thing that you need to know, right? What is the difference between quality assurance and quality control? What is the difference between this is quality assurance, and quality control? Can somebody tell me the difference between quality assurance and quality control? What is the difference between quality assurance and quality control? Tell me, guys.
So quality assurance is basically to check whether the product we are making is correct. And quality control is basically the process that we take.
आपने रिवर्स कर दिया बस, बता सही रहे हो बिल्कुल. बता बिल्कुल
अच्छा
ठीक
हाँ
है।
करेक्ट क्वालिटी एश्योरेंस जो है वो प्रोसेस चेक करता है और क्वालिटी कंट्रोल जो है वो प्रोडक्ट चेक करता है।
बिल्कुल हाँ, लेकिन मार्केट में उल्टा यूज हो रहा है। जब ये मार्केट में टेस्टिंग टीम को भी क्यूए टीम बोलते हैं, राइट?
करेक्ट।
और ये बड़ी हैरानी की बात है यार, सिक्स सिग्मा आईएसओ के टाइम से हमें ये बताया जाता है। सी आई डिड माय फर्स्ट क्वालिटी ट्रेनिंग बाय एसटीक्यूसी, जो गवर्नमेंट का डिपार्टमेंट है, दैट वाज ऑन आईएसओ एंड इट वाज इन द बिगिनिंग ऑफ माय करियर। And you know, with great emphasis, they told us difference between quality assurance and quality control. तब से देख रहे हैं, मतलब जितना भी हम see, you know, it was taught to us when we were getting trained on ISO. It was taught to us when we were trained on CMMI, right, within the organization. But उसके बाद भी market में testing को बोलते हैं. But again, you know, we have to follow standards. So, what is quality assurance? देखो, quality assurance validates whether you are following standards, guidelines, and processes, right? Quality assurance validates whether you are complying to standards, guidelines, and processes. Now, in other words, quality assurance validates whether you are doing work in a right, or whether you are creating the product in a right way or not, or you are doing work in a right using right process procedures or not, right? This is quality assurance. Now, quality control means any kind of inspection, testing, and review. Now, quality control is performed when a deliverable is created. When you create a deliverable, right, you perform quality control, right, after creation of deliverable. But quality assurance is a end-to-end process. Quality assurance is an end-to-end process, right? Right from the beginning till the end. For example, am I using the right version of the business case template? Has it been filled correctly? Is a quality assurance. Am I using the right version of project charter? Right? Quality assurance, right? Am I using right method to perform the work? Am I using right method to perform acceptance testing? So it's a quality assurance is more like an end-to-end process, right? Whereas when I say control quality or quality control, it is inspection, testing, or review. Is that okay? Is the difference between control quality and quality assurance clear? Right? Is it clear, guys? Now, Aditya, do you understand the difference between quality control and quality assurance? Aditya, is it okay?
Yes, Pankaj.
Right? Anushri, is it okay? Charu, Isha, is the difference okay?
Yes, Pankaj.
Perfect. Right. So shall I move forward? Now, now what we'll do is, first we'll go through quality management plan. I'll show you some of the contents of the quality management plan. Right? Can we see some of the contents of the quality management plan, guys?
Sorry, Pankaj, can you just rephrase the difference you just
देखो,
explained?
मैं एक बहुत सिंपल सा एग्जांपल लेता हूँ कि आपने आप यू हैव अ मोबाइल फैक्ट्री, राइट? और मोबाइल फैक्ट्री में मोबाइल बन रहे हैं। अब मोबाइल ठीक चल रहा है कि नहीं चल रहा है, वो कैसे वैलिडेट करोगे? टेस्टिंग करके करोगे ना, नितिन?
Yeah, correct.
उसे क्या बोलते हैं हम? क्वालिटी कंट्रोल बोलते हैं,
Okay.
राइट? क्वालिटी एश्योरेंस क्या है? मैनेज क्वालिटी का एक कंपोनेंट है। देखो, क्या सब लोग प्रॉपर डिसिप्लिन, प्रॉपर मेथड्स के साथ सही तरीके से मोबाइल बना रहे हैं? आर दे फॉलोइंग राइट प्रोसेसेस टू क्रिएट द मोबाइल, राइट? सो वो प्रोसेस को बोलते हैं हम क्वालिटी एश्योरेंस। जब व्हेन वी वैलिडेट प्रोसेस कंप्लायंस, दिस इज कॉल्ड एज क्वालिटी एश्योरेंस। इज दैट ओके?
Yeah, Pankaj. Okay.
Now, let's see quality. How does a quality management plan looks? This is the first process, right? This is the first step or process in quality. The most important is end-to-end. See, quality management plan, it's a kind of it's a plan that is kind of a rules of game for managing the quality. It sets approach for managing the quality, right? So what all does a quality management plan, right, or a quality plan? You use it with different names, right? Quality plan, or development and quality plan, right, or quality management plan. A quality management plan consists of all these activities, right? First, quality standards that will be used by the project, right? Now, can you give me some example of quality standards? Now, you can have your own internal standards. You can follow ISO standards. You can follow Six Sigma. You can follow ISO standards, CMMI standards, right? So those standards, right? Quality goals or objective of the project. Now, quality goals or quality objectives of the project can be written in the form of key performance indicators or metrics, right? For example, the defect, the affect, the expected defect rate or defect density, right? Or escape defect, right? The roles and responsibilities of people associated with the quality can be defined in the quality management plan. The list of project deliverables and process subject to quality review, right? Quality control and quality management activities planned for the project. Quality tools that will be used for the project, right? Any kind of testing tool that you will use like Selenium or WinRunner or LoadRunner or anything else can be part of quality, right? This section, right? And the last one is major procedure relevant for projects such as dealing with non-conformance, corrective actions, procedures, and continuous improvement procedures. So this would be there in the quality management plan, right? Now, this document can exist, right? Because you don't need to recreate for every project. This may exist for at an organizational level, and you can reuse and modify if required for your project. Now, we discussed that there are three processes: quality management, right? Planning, quality planning, quality assurance, and quality control. Now, all these three processes will use 7 quality control tools, right? These 7 quality control tools are taken from Six Sigma, right? Now, let's go through all the 7 tools. We'll start with control charts. We'll start with control charts, which is the first tool. Now, guys, can you see control charts in front of you?
Yes.
Can you see control charts? Can you see this chart? The trend now. Can you see this chart where I am pointing?
Yeah.
Now, see in this chart, the y-axis, this y-axis is any performance, right? And this x-axis is time, right? Now, if y-axis is performance, the x-axis is time. Can I call it as a trend? Is it a trend, guys, or not? Can I call this as a trend? Is it a trend or not? Now, when I say y,
Pankaj, trend is something which is repetitive, right?
any trend, right? Any trend. See, again, a trend can be cyclical trend, right? A trend can be a linear trend, right? A trend can be a seasonal trend, right? So trend can, trends also come in different format. It doesn't mean that, trend should go in one direction, up or down, right? It can be cyclical also like this, right? It can be seasonal also. So again, but anyways, first thing, this is a run chart or a trend chart. But the first important thing, see, this horizontal line is a time and the Y is performance. Now see, any performance can be represented by 2 types of data, right? Any performance can be represented by 2 types of data. It can be continuous. The data can be continuous, random, or continuous, right? Continuous data or continuous random data or discrete data. Now tell me, what is the difference between a continuous data and a discrete data? What is the difference between a continuous data and a discrete data? Can somebody tell me? What is the difference between a continuous data and a discrete data? Anybody can try, right?
Discrete may be where we are not having a regularity in the data.
See, I'll tell you what. The simple way to understand is, a discrete data is a data that can be counted. And continuous data is a data which can be measured, right? A discrete data can be counted, right? Whereas continuous data can be measured, right? Now, for example, if I say number of defects, is it a discrete or continuous data? If I say number of defects, if I say number of apples, oranges, they're all discrete data. Continuous data is a data which can be measured, right? For example, response time of a web server or an application or a hardware or a software. Is it a continuous data or not? Speed of a car, right? Such data, the data which can be measured is a continuous and which can be counted is a discrete. So what I mean to say here is, see the y-axis is any performance, right? And this is time. This performance can be a continuous data like response time of a web server, right? Or a software or a hardware, right? Or it can be a discrete data like number of defects over a period of time. Is that okay? Is that okay, guys? Ritesh, are you okay with this? The difference between continuous data and discrete data?
Yes, Pankaj.
Right? Anushri, Aditya, are you okay? Are you okay with the difference?
Yes, sir.
Perfect.
Yeah.
Now, what is a control chart? Why do we need control chart? See, the basic, goal, purpose or objective of a control chart is to isolate or to segregate or to separate, special causes from a random cause, right? The basic purpose of a control chart is to segregate a special cause from a random cause, right? Now, see any performance. Now, tell me one thing. Any performance. Does anyone perform in a horizontal line like this? Nitin, does anyone perform in a horizontal line like this? For example, even if the stalwarts like Tendulkar, right, or Virat Kohli, right, or from tennis you can take people like Federer or Djokovic or Nadal, right? Do they play like this? Is there the outcome of their game like this?
No, should not be.
Right? Generally, they also lose or not?
Yeah, correct.
Right? If I see the game, if let's say Tendulkar, right? If this is an average, his performance will be something like this. Right? Yes or no?
Yeah, correct. Okay.
Now see this. Can I call this as a variation in performance?
Correct.
Right? Now the variation in the performance can happen because of two reasons. Right? One is a special cause, another is a general random variation in the performance. Right? अब एक चीज बताओ हमें, देखो जैसे तेंदुलकर जितनी मेहनत करेगा, अगर तेंदुलकर मेहनत करेगा, प्रैक्टिस करेगा, तो उसकी जो स्टेबिलिटी है वो बढ़ेगी कि नहीं बढ़ेगी? His variation will become lesser and lesser or not?
Yes.
Right? देखो जैसे जैसे कोई भी मेहनत करता है, if anybody work hard, right? तो क्या होता है? सपोज पहले वो ऐसा था, right? पहले वो ऐसे चलता था, सपोज ऐसे मेहनत करने से क्या होगा? वो obviously practice makes the man perfect to some extent, right? To a great extent. So will the variation decrease or not? Variation around the mean decreases or not? Yes or no?
Yeah, it will.
Yes or no?
Yeah, correct.
देखो अब क्या होता है, जो रैंडम वेरिएशन की वजह से परफॉर्मेंस खराब हो रही है वो तो इंप्रूव हो जाएगी प्रैक्टिस से. If we have a good coach, mentor, he helps us to identify our weak points, he strengthens us around weak points. But tell me, many times the variation is because of special cause. Now, special cause का treatment भी वही रहेगा या अलग रहेगा? Special cause का मतलब क्या
अलग
है?
रहेगा.
Tendulkar was suffering from a back problem, right? Consistently he had a back problem and he scored less runs. Is he a special cause or a random cause?
Special cause.
It's a special cause, right? So ये practice करने से improve होगा या उसकी back को ठीक करने से improve होगा?
back tick.
अब इस पे अगर in this case, if the coach of the Indian team says you have to practice hard, is it a right statement or wrong statement?
Wrong. Yeah,
Wrong.
yeah, wrong.
But see, I am giving you examples which are very clear, but many times it happens. We often take random, special cause is a random cause and give the same treatment. Right? For example, a child was not performing well in the class. A kid was not performing well in the class, right? His parents were told, he has to work very hard. Now, after some analysis, right, the parents came to know that the kid was 2 years younger than every other classmate, than his fellow classmates. Now tell me, if a kid is 2 years younger than the fellow classmates in the early classes, can he match up to the speed of the kids who are more than 2 years old?
No.
Is it a special cause or a random cause? Special cause. But the teacher, when the teacher says he has to work very hard, was she treating it as a random cause or a special cause?
Random.
So, it happens many times without understanding whether it is due to a special cause or a random cause, right? We apply the same diagnosis. See, random, if the performance variation is because of a random reason, it requires a different diagnosis. If it is because of a special cause, it requires a different diagnosis, right? Is that okay? Now, how we are able to isolate a random, that variation is because of a random cause or a special cause through a control chart, right? Now, see, the reality is, there are many, if you go with a typical Six Sigma training, there are around 14 different trends that shows a variation because of a special cause. But in PMP, we will focus on the two only, right? Not more than two, right? That one special cause is when a point lies above the control limit or below the control limit, right? It is attributable to a special cause. Now, why it is attributable to a special cause, I'll tell you. See, the upper control limit is held at 3 sigma plus, and the lower control limit is minus 3 sigma, right? And I told you that, the data that lies between plus minus 3 sigma is how much? 99.97%, right? Now see, if 99.97% people are within this range, why there are very few 0.23% people who are above the control limit or below the control limit? Should we do a root cause analysis on this or not? Can it be because of a special cause? See, why only 0.2% people are above or below? Can we do a can it be because of special cause?
Yes.
So this is one. This is one reason, right? Second is, this one. Now, can you see this data? Now, all of a sudden, can you observe 7 consecutive points lying on the same side of the mean? Can you see 7 consecutive points lying on the same side of the mean? All of a sudden, right? Though they are within control limits, right? But see, the data was going up and below the mean. All of a sudden, 7 points, 1, 2, 3, 4, 5, 6, 7. These 7 points are on the same side of the mean. Now, should I do an analysis here or not? Should I do an analysis here or not? Tell me. Should I do an analysis here or not? देखो डेटा ऐसे फ्लक्चुएट कर रहा है, ऊपर नीचे अचानक डेटा ऐसे आ गया, मीन ही चेंज हो गया, तो मैं उसे वो किसी वजह से तो होगा. Should I do a root cause analysis here?
Yes.
Right. So when 7 consecutive points are on the same side of the mean, right, it can be attributable to a special cause. Now, see, it's not necessary that it has happened because of something bad. Because you might have automated a process, right? Because of that, mean would have changed. There could be negative reasons also. For example, somebody who's capturing the defect, right, is manipulating the data. Somebody might not be capturing the defects, right? Some untrained person have been put here, right? Or you might have modified the process, which has resulted into a better average, right? So there can be any reason, but again, this change is because of a special cause, right? Are you getting my point or not? Now, I have given you two situations, but tell me one thing. Even if a situation happened like this, right? Will you be skeptical or not? See, the data goes like this. Suppose the data is going like this, right? Like this, like this. This is the usual trend, right? Right. Now, all of a sudden, the data start going like this. Would you do a root cause analysis here? Should you do a root cause analysis here? Yes or no? Is it too good to be believed as true? Yes or no? Ritesh, tell me, if the data all of a sudden, it was fluctuating like this around the mean, but all of a sudden it is going like this. Should you do a root cause analysis or not?
Of course, because this shows that something is happening maybe
Something
within the
is
control.
so that's what. See, in PMP, I'll only show you two. One is above the mean, below the mean, and rule of 7. But if you do a Google, right, say, 14 different unusual trend in a control chart, they will show you all. Suppose, constantly data is at 1 sigma level only, right? Suppose points are increasing all of a sudden, there's an increasing or decreasing trend. So they will show you all the different trends, right? But from PMP perspective, only remember when a point is above the control limit or below the control limit, the process is out of control and it can be because of a special cause, right? The second is when 7 consecutive points lie on the same side of the mean, it is also attributable to a special cause, right? Is that okay? So this is in brief about control charts, right? Now, we'll go through the second quality control tool, right, which is Ishikawa diagram, right? This is also called as fishbone diagram. These are also called as cause-effect diagram. And, the cause and effect diagrams are based on a concept called as 5 whys of management. 5 whys of management, right? Have you heard of 5 whys of management? Have you heard of 5 whys of management?
Yeah, heard only, Pankaj, not
Okay,
much
no
in
worries.
a detail.
So,
Yeah.
no worries. So what is 5 whys, right? Now see, whenever a problem happens, right? See, this is a problem. Can you see the problem here? This is the problem. Now, problem can be suppose the problem is number of defects have increased. Now, if this is the problem, can you find out 5 reasons for it? If the number of defects have increased, can skills missing be one of the reason? Can lack of skills be one reason? Yes or no? Lack of skills can lead to defects, right? This is one reason. What can be the second reason? Mismatch of skills can be the reason. Third, absenteeism can be the reason, right? Careless work can also be the reason. Process absent can be the reason. So these are first 5 why. Now go into every why, right? For example, this was the first why, lack of skills. Then ask why lack of skills. It can be because of multiple reasons, right? One reason can be, lot of attrition in the company, people leaving the organization. Second reason can be, mismatch of the skills while recruitment, right? So there can be multiple reasons. So what you do is you keep on drilling down, and so that you get all the probable reasons, right, for this problem. Now later you will see how this, see, through this Ishikawa diagram or fishbone diagram or cause and effect diagram, you will get all the probable causes for a defect. But see, all these, probable causes may not be relevant for the defect. So what we'll do is through Pareto analysis later, we'll identify the major reasons, right? The biggest root cause. Now, how it is done, you will see shortly. This is the second one. This is the second quality control tool. The third one. The third one is flowchart, right? Now, flowchart is used to depict process analysis. It represents a workflow from start to end of the process, right? These are all process steps, right? Then if there's a decision to be, if there's a decision involved, so the decision will be shown through a diamond sign and then process, right? Now, flowchart is primarily used to analyze processes, right? And we have been using it since very long. I think the school kids also use flowcharts, so I don't think I need to describe a lot on flowchart. Right now, I'm straight away moving to the fourth tool, which is called as Pareto chart. Now, Pareto chart is based on Pareto law. Now, can anybody explain me what is a Pareto law? Right? Can anybody explain me, guys, what is a Pareto law? What is a Pareto law, guys?
I think 80% of defects come from 20% of functionality, or I mean.
Yeah, he's right. Yeah. So
No idea, Pankaj. No.
I am saying. See, it says, now this is what the law says. See, Pareto is based on 80-20 rule, right? I'm writing here 80-20 rule. 80. Can you see 80-20 rule written here? Right. Now, what is 80-20 rules? What is a 80-20 rule? Tell me, guys, think and tell me. What is a 80-20 rule?
So Pankaj, in 80-20 rule, we have like 80% of maybe like a task is performed by 20% of the team, or 80% of the defects are being caused because of 2% of the maybe.
Yes. So, 80-20 rule means 80% of the problems are because of 20% reasons. Can I say this? Right? And if you fix those 20% reasons, right, 80% of the problems are solved. Can I say this? Can I say this? This is what you have said, right? 80% of the problem in any system are because of 20% reasons. Right? Yes or no? Are you following it? When I say 80% of the problems are because of 20% reasons, right? Are you getting it or not? Right. Somebody, I think it was Shelja who defined, right? Shelja?
Yes, Pankaj, right.
So
that's
am I saying what you have said?
Right, Pankaj, that's correct.
So we have to focus on vital fews. So through it, when I say 80-20 rule, can I say like this? Majority of the problems are because of vital few reasons. Is the meaning this or not? Majority of the problems, right, in the system are not because of randomly spread reasons. They are because of vital few reasons. Can I say this? Right?
Yes.
So, as far as the actually logic or meaning is concerned, whether it is 80-20 or 90-10, both work, right? It is called as 80-20, but it can be 90-10 also, right? Now, see, this rule is applicable everywhere, right? In real life also, right? Nitin, are you married or unmarried?
Married. Pankaj married.
Married, right? देखो आप देखना ध्यान से, आपकी वाइफ और आपके बीच में झगड़ा या कॉन्फ्लिक्ट 20% रीजंस की वजह से होता है ज्यादातर, बहुत सारे, राइट? आप देखना, आप अगर अपने टॉप 3 चीजें ठीक कर लोगे ना, वो सारे झगड़े बंद हो जाएंगे. Are you getting my point or not?
Yeah, getting.
So, देखो अगर आपका, if you have a conflict, it is, see again, this rule is applicable everywhere, right? For example, if you talk about conflict between husband and wives, conflict between subordinates, right, and superiors, between friends, between roommates, अगर उनका conflict भी देखोगे आप, it's not because of randomly spread reasons, it is because of 80-20. Right? Now see, for example, now 80-20, the focus is to collect vital few.
Pankaj, is that ratio is fixed or it
नहीं
can
वही
be?
बता रहा था, वही मैं बता रहा हूँ. देखो 80-20 का मतलब ये नहीं कि 80-20 फिक्स कर दोगे आप. मैं बोल रहा हूँ, see what I'm trying to say is majority of issues are because of vital few reasons. इसको 90-10 भी कर सकते हो आप. Now let me explain. See, I used to have a boss, right? And he would always tell me, Pankaj, in every process improvement, he will tell you like this. He will say, Pankaj, we know that we have n number of issues in our system, right? But I want you to focus on top 3. When my boss would say, focus on top 3, right? Doesn't it mean that, he's asking me, he's pointing towards 80-20 only?
Yes, that's true, Pankaj.
Right? So, the rule can be stated in any way. You have to understand the meaning of the rule, right? Are you getting my problem? Sorry, are you getting what I'm trying to say?
So it can be, 70-30 also. Huh?
देखो 70-30 थोड़ा ज्यादा हो जाएगा, राइट? थोड़ा सा ज्यादा होगा 70-30, बट हाँ हो सकता है. देखो मैं देखो जो मेजॉरिटी ऑफ प्रॉब्लम्स है वो छोटी सी चीजों के कारण होती है, और अगर वो फिक्स कर लोगे आप तो सब काफी कुछ ठीक हो जाएगा, राइट? नाउ हाउ टू आइसोलेट, हाउ टू फाइंड इट आउट थ्रू अ परेटो चार्ट. लेट्स सी. देखो ये परेटो देखते हैं, राइट? कैन यू सी दिस बार चार्ट? देखो बार चार्ट क्या रिप्रेजेंट कर रहा है? This bar chart is showing various workstations. Workstations के serial number यहाँ पे भी have been represented. Now these are the serial numbers of the workstations. ये सारे workstations हैं. 9 है, 3 है, 8 है, ये serial numbers हैं. 2 है, 5 है, 6 है, 4 है, 10 है, 1 है. These are different workstations. Now ये second row है, ये बता रही है number of defects in the workstation, right? Now tell me one thing. How many defects are there in workstation 9 as per this? 27. Number of defects are 27 on workstation 9 or not? यहाँ पे आ रहा है, देखो 27 लिखा हुआ है. तो 27 का मैंने बार चार्ट बना दिया. ये वर्कस्टेशन 3 में कितने डिफेक्ट्स हैं? Tell me. 9. So ये 9 का बार बना दिया मैंने. But I'll make this bar of 9 plus what are the total number of defects if I sum defects in 9 and 3? Is it 36?
36.
27 plus 9, 36, right? Workstation 8 में कितने defects हैं? How many defects are there in workstation 8?
9 again.
9 again. And the total will be 36 plus 9, 45. Right? Workstation 4 में कितने 2 में कितने defects हैं? 4. This is 4, right? And if I add 4 to this, it is how much? Around 49, right? So I'll keep on doing it. अब इस पूरे ग्राफ को देखो, इसमें अगर हम 80% डिफेक्ट आइसोलेट करते हैं, लेट मी आइसोलेट 80% डिफेक्ट्स. देखो 80% यहाँ पे आ रहे हैं. Now if I draw a line like this,
49 तक.
यहाँ तक आ रहा है, right? Can I say first 4? Right? If I draw it here like this, can I say first four workstation 9, 3, 8 and 2, they are leading to 80% of the defects? देखो टोटल डिफेक्ट 80% खाली 1, 2, 3 का इनका सम है. 9, 3, 8, 2 इनका जो सम है, राइट?
Yes, Pankaj, that's right.
तो इनकी वजह से, इन 4 की वजह से 80% डिफेक्ट आ रहे हैं. Now if I fix 9, 3, 8 and 2, my 80% of the problem will be solved. Yes or no?
Right.
Right. So this is what we do in Pareto. We try to identify vital few. Now, Pareto is actually used in combination, right? It's used in combination of Ishikawa, right? Ishikawa will give us all the probable reasons for a problem, and then we'll identify vital few using Pareto. Now, how do we do it? Let's see. Right? Let's see how Pareto and Ishikawa can be combined together to find out the vital fews. Let's see. Look at this. Now, before I explain you this chart, look at this chart from this point till the end, right? Then we'll discuss. So guys, did you get the idea about this? Suppose this is the problem, right? Insufficient, reliable release. The problem can be anything. It can be increase in the number of defects. Now, if I apply Ishikawa, will it give me huge number of reasons why it has happened? I'm doing 5 whys, right? So it will give me all the probable causes. But tell me, are all the probable causes equally important? Are all the probable causes equally important? Tell me, guys. Or should I find out the biggest root cause using Pareto? Those 20% reasons or causes which are leading to 80% problems. Can I find it out? Yes or no?
Yes, Pankaj.
Yes.
Right? Then what I'll do is, now I know the biggest root cause, so I'll restate the biggest root cause, right? Brainstorm the solution, and I can have any Excel sheet or backlog where I can put it, right? Or if I want to integrate it with the product, the development, I can use the product. I can write all these corrective measures in product backlog also, right? Now, see, just one thing I would like to address here. See, do you remember definition of done in Agile? Do you remember definition of done, guys? Right? At sprint review, you accept, right, product based on definition of done. And when you see the checklist, which is definition of done, it is both, they are both QA and QC items, right? So is this flow clear to all of you? Right? How do we use this Ishikawa or fishbone and Pareto together? Is it clear to all of you? So shall we move to the fifth one? The fifth one is histogram, right? Histogram, right? What is this? Histogram, right? Now, again, this is again a bar chart, right? See, yesterday we did tornado diagram. Remember yesterday, to assess the risk, we did tornado diagram. Today
Yes.
that was also bar chart. Today we did Pareto, that was also bar chart. This is histogram, this is also bar chart. But again, the purpose and the use of all the three are different. Right? Now, see, if you have to represent different categories, right, of a variable, right, or of a data at the same time, at the same point of time, you have to show any kind of different categories, right? The categories can be different types of defects, right? Or it can be different types of skills, or it can be different types of issues, right? You use histogram. Now tell me, these are number of days. On a single day, are you displaying different types of bugs or defects? See, these different colors are different bugs like dirty core, raised studs, off center, mixed plugs, bad plating. Are these different ones or not? Yes or no?
Yes.
Right? They're different ones, right? So this is a histogram, right? Now tell me, can you use histogram to depict a staffing management plan? In a staffing management plan you display various kind of skills, right? And suppose this time interval, this is 1 month, 2 month, 3 months, or whatever. You can show different skills required at different point of time in the project. For example, in first month, you might be requiring a BA, less number of developers, right? Then second month you require less number of BAs, more developers, then testers also. So you can use it for a staffing management plan also. Guys, so are you getting what is meant by histogram? Why do we use it? Are you okay with this histogram, Vishal?
Yes.
Yes, Pankaj.
Vishal, are you there?
I think he has texted. He's away for some time.
Sorry, Sun is unwell. I just
Yeah.
checked. Now, the sixth one. The sixth one is check sheets. Right now, see, unlike other tools, check sheet will only give you data. It will not give you information, right? Now, if you see this, have you seen these type of check sheets in restrooms of your office, in different malls? Have you seen these check sheets in your restrooms?
Yeah.
Yes.
Yes, yes.
Right? Now they are more relevant to operational kind of a work. Now in a check sheet, you can use, for example, I'll describe you this check sheet. For example, these are the components number. Can you see components? Part number X101. Part number means a component, right? It can be a capacitor, it can be anything else, right? It can be an IC, or it can be anything. Now, for example, in this part number, if you find a cold solder bug, you will put a single bar. If you find a second bug, second bar. Third bug, third bar. Fourth bar. And then if there are 5 defects, you put a line like this. This means 5. And for 6 defect, you will again start. 6, 7, 8, 9, and then bar. So, in a day, you can divide a day into intervals, right? For example, in the morning time, let's say 8 to 10, then 10 to 12. So at different intervals, you can see all this. You can assess this data, right? The part numbers, and for example, in restroom it can be different, right? For example, one issue can be absence of the toilet roll, right? Or it can be wet toilet roll, so you can assess these issues, right? And later these, and you can give these issues to the team. Later it can be converted into information, or maybe in the form of a Pareto or a histogram, right, for analysis. So is it clear what is check sheet, guys? What is the check sheet, guys? Is it clear to all of you or not?
Yes,
Yes,
Pankaj,
Pankaj,
that's
sir.
clear.
Right. Now the last tool is scatter diagram. Scatter diagram is used to depict relationship between multiple variables. Right? Scatter diagram is used to depict the relationship between multiple variables. Right? For example, this is one example given here. It's a relationship between what? The satisfaction score and the percentage of volunteer attending the training. Percentage of volunteer attending the training, right? Now, what you do is, you create a best fit line. Can you create a best fit line like this based on this data? Right? There's a method of creating it, a best fit line. Now, suppose you create a best fit line. How can it help you? See, it can help you in prediction. See, when you create a straight line like this, a straight line like this can always be represented in the form of y is equal to ax plus b, right? A straight line like this can be represented in the form of ax plus b. Yes or no? Or mx plus c, right? Do you remember this equation? A is the slope, b is the y-intercept, right? Now, tell me, what is the benefit of this? See, if I create a linear relationship like this, what will be the further benefit? If I create a relationship like this, using this line, what is the benefit?
So I think by this we can create a benchmark, or maybe,
Yeah. Since I have line, see, since I have this line, by taking any two values, any 2 points on the line, right? I can always find A and B, right? After finding A and B, because I can take any coordinate x and y value, take x and y value from here or here. This becomes 2 linear equations and it can be solved. So ultimately this will take a form of this. Ultimately, this line will become like this. Anything, I'm taking a dummy value right now. The actual values may be different. It may take the form of this. Y is equal to 7x plus 3. Now tell me, if I get a relationship like this, y is equal to 7x plus 3. Now, can it help me to forecast? Because I have a data till this, right? For example, if the percentage of volunteer attending the orientation are 100, satisfaction score is this. But if I have
Pankaj, where have you got from y is equal to x plus b?
See, this is a standard equation for this linear line. See, a line like this, can be represented by y is equal to ax plus b, where a is the slope and b is the y-intercept, right? This is basic mathematics.
Okay, you're talking about the mathematical equation. Okay.
Okay, I'm not getting this formula.
नहीं भी आ रहे तो कुछ फर्क नहीं पड़ता यार. EMI इतना नहीं पूछेगा. देखो, आप सिर्फ ये मान के चलो कि स्कैटर डायग्राम प्रिडिक्ट करता है रिलेशनशिप बिटवीन 2 वेरिएबल्स. तब इससे क्या पता चल रहा है आपको? मैं इसलिए बता रहा था आपको कि इसका आगे का यूज बता रहा था. ये प्रिडिक्शन के लिए यूज होता है, राइट? प्रिडिक्टिव एनालिसिस में यूज होता है इसका काम. बट आपके लिए अभी देखो, पीएमआई के लिए कितना काफी है. आप एक चीज नोट कर रहे हो यहाँ पे नितिन, कि as this x-axis is increasing, as a data, as percentage of volunteer attending the orientation, as it increases, satisfaction score also increases. इतना समझ आ रहा है?
Yeah.
If this is x, this is y. If x is increasing, y is also increasing. समझ आ रही है?
Yes, correct.
तो इससे हमें क्या मिल रहा है? इसका मतलब है जो कोफिशिएंट ऑफ कोरिलेशन है दो वेरिएबल्स का, वो पॉजिटिव है. The two variables are directly related. The two variables are directly related, right? और इनका कोवेरियंस भी पॉजिटिव होगा. दूसरा सिचुएशन क्या होती है? दूसरी सिचुएशन ये है कि कभी-कभी जो डेटा आता है वो ऐसा आ जाता है. देखो, अगर सपोज मैं प्लॉट करता हूँ डिफेक्ट्स और प्रोडक्टिविटी को, का डेटा ऐसा होगा. As the number of defects increases, productivity decreases. तो इस केस में क्या हो रहा है? जैसे जैसे x बढ़ रहा है, y डिक्रीज हो रहा है या ऊपर हो रहा है? इस केस में क्या हो रहा है नितिन, बताओ. ये x है, ये x है और ये y है. ये x है और ये y है. तो जैसे जैसे x बढ़ रहा है, y घट रहा है कि नहीं घट रहा? Is y decreasing as x increases? हाँ नितिन, आपको समझ आ रहा है?
No, Pankaj, that is why I'm just trying to understand.
ये लाइन का मतलब क्या है, ये डिक्रीजिंग ट्रेंड का? इसका मतलब ये है कि जैसे जैसे मैं x को बढ़ा रहा हूँ, y घट रहा है. This x can be number of defects. इसको मैं डिफेक्ट्स क्या देता हूँ, राइट? What is y? y suppose productivity है. Now tell me, if the defects increases, the productivity will decrease or not? Yes or no?
Yeah, correct. Now I got it.
बस खाली क्या होता है इस पूरी स्कैटर डायग्राम से क्या होता है, हम डेटा लेके रिलेशनशिप देखते हैं वेरिएबल्स की.
तो डिफेक्ट अगर इंक्रीज हो रहा है तो हमारा प्रोडक्टिविटी
हाँ, तो इसको बोलते हैं डायरेक्ट रिलेशन,
हाँ.
राइट. और इसको बोलते हैं इनवर्स रिलेशन. एक बड़े
प्रोडक्टिविटी इंक्रीज डिक्रीज हो रहा है ना हमारा, डिफेक्ट इंक्रीज हो रहा है.
हाँ डिफेक्ट, हाँ ये डिक्रीज हो रहा है. अब देखो बहुत बारी क्या होता है, बहुत बारी हमारे पास डेटा ऐसा भी आ जाता है. समटाइम्स यू गेट डेटा लाइक दिस. सपोज डेटा इज लाइक दिस. देखो अगर डेटा आपका ऐसे आ गया, आपने प्लॉट किया एक्स और वाई को, कोई दो वेरिएबल प्लॉट किए, राइट. अब वो प्लॉट करने पे डेटा ऐसे आ गया आपका. सपोज अब इसकी तो बेस्ट फिट लाइन कुछ हो ही नहीं सकती है. चारू, क्या हम बेस्ट फिट लाइन बना सकते हैं इसकी केस में? ऐसी लाइन बना सकते हैं हम बेस्ट फिट, अगर ऐसा प्लॉट है हमारा तो. चारू, आर यू
You
देयर?
said sometime, yeah, you said sometime back there is a rule to draw the line. So,
देखो
to the best of my knowledge, मैथमेटिक्स इतना मुझे याद है, स्कैटर्ड में भी लाइंस ड्रॉ हो जाती थी.
होती है. तो ये क्या है, स्कैटर में हमने लाइन ड्रॉ की, बेस्ट फिट लाइन बोलते हैं इसे,
करेक्ट.
राइट. बेस्ट फिट लाइन. बट ऐसे में बेस्ट फिट लाइन बना पाएंगे हम? नहीं बना पाएंगे, राइट. देखो ये वाली बेस्ट फिट लाइन हमने इसलिए बनाई होगी क्योंकि हमारे पास डेटा कुछ ऐसा होगा, ऐसा, ऐसे पॉइंट्स आ गए हमारे पास, राइट. ऐसे पॉइंट आ गए, ऐसे पॉइंट आ गए, ऐसे पॉइंट आ गए, तो हम बना देंगे बेस्ट फिट लाइन. बट ऐसे में क्या बनाएंगे हम? बेस्ट फिट लाइन का मतलब है कि मिनिमम एरर फ्रॉम द एक्चुअल दिस, राइट. क्योंकि बेस्ट फिट लाइन से हमें प्रेडिक्शन में हेल्प मिलती है, ठीक है. अब इसके केस में हम बोलेंगे इफ यू आर गेटिंग पॉइंट्स लाइक दिस, x and y वेरिएबल हैव नो लीनियर रिलेशनशिप, राइट. अगर स्कैटर का डेटा ऐसा आ गया, देखो ये ऐसा डेटा आएगा तो पॉजिटिव रिलेशनशिप, ऐसा आएगा तो नेगेटिव, ऐसा आएगा तो दे डोंट हैव एनी लीनियर रिलेशनशिप. इज इट ओके? देखो मैं आपको
What kind of questions do we expect है for this
कुछ नहीं
scatter diagram?
हाँ, बस खाली ये बोल देंगे रिलेशनशिप. लेकिन आपको थोड़ा सा मालूम हो तो बेटर है. देखो क्या होता है कि समहाउ अभी अगर आप ये रिलेशन देखो, बहुत इजीली अगर आपने बेस्ट फिट लाइन बना ली तो आप ये ए और बी की वैल्यू निकाल लोगे. इतना समझ आ रहा है कैसे निकालोगे? मैं बता के दिखाऊं कैसे निकालोगे? एक काम करते हैं, मैं बताता हूँ ए बी कैसे निकालोगे. आप एक वैल्यू यहां से ले लो, इसमें व्हाट इज एक्स हियर, कितना एक्स बताओ? 20 है और वाई 4 है. एक्स 20 और वाई 4 है यहाँ पे इस पॉइंट का, राइट. तो आप एक काम करो, इसमें सब्स्टिट्यूट करो. यहाँ पे वाई क्या है? 4, एक्स क्या है? 20, ए 20 प्लस बी, ये सब्स्टिट्यूट हो गया. अच्छा, अब दूसरा एक पॉइंट और ले लो आप, कोई जो थोड़ा आसान से देखिए, इसको ले लो. इस पॉइंट में एक्स क्या है? 40 है और वाई क्या है? 6 है. इस पॉइंट की बात करता हूं मैं. ऐसी है ना वैल्यू 40 और 6. अब यहाँ पे इसको सब्स्टिट्यूट करते हैं हम. देखो इसी इक्वेशन में y क्या है? 6 है, x क्या है? 40, x प्लस b. अब इतना कर सकते हो आपकी, सॉरी 40a प्लस b, सॉरी ये तो डिफरेंट होगा, सॉरी 6 is equal to 40a प्लस b, राइट. तो चारू इसमें अब a और b तो निकाल लोगे आप, दो इक्वेशन बन गई. Can you find A and B in this linear equation or not? निकाल सकते हो और भी? Ritesh, can you find out A and B in these two equations? Ritesh, can you find out A and B? Shelja, can you find out A and B? Anybody? बहुत easy होता है. Anushree,
1 second, sir.
हाँ, बहुत आराम से निकल जाएगा A B. आप एग्जैक्ट वैल्यू निकालो A B क्या आ रहा है.
Yes, Pankaj, we can find that. I mean,
अब
I can also do that.
देखो उसका फायदा प्रिडिक्शन में होता है. देखो मेरे पास डेटा कहाँ तक का है? 100 तक का. अब मुझसे कोई पूछे अगर if percentage of volunteer attending orientation are 120, I don't have data. तो मैं यहाँ पे इक्वेशन निकाल के वो भी निकाल सकता हूँ कि नहीं निकाल सकता? ये बताओ. Can I find out this or not? Yes or no? Yes or no? क्या है X और A और B क्या आ रहा है आपका आदित्य?
So 0.1 and 2.
कितना आ रहा है?
A equal to 0.1, B equal to 2. पहली दो इक्वेशन से.
Y is equal to A 0.1 आ रहा है ना?
Y2.
Y2 आ रहा है. Y थोड़ी आएगा. A भी
Sorry,
निकाल.
A 0.1, B2.
हाँ, A is equal to 1/10x.
1/10, yes.
1/10 into X और B क्या आ रहा है?
2.
प्लस 2. ये इक्वेशन बन गई हमारी. देखो अब इसका फायदा क्या होगा हमारे पास डेटा कितना है यहाँ पे चारू? 100 तक का डेटा है ना. 120 का तो नहीं है, 140 का तो नहीं है. अब यहां से हम निकाल सकते हैं. सपोज हमसे कोई पूछे व्हाट इज द सेटिस्फैक्शन स्कोर इफ द नंबर ऑफ वॉलंटियर्स आर 120. कितना होगा बताओ आदित्य? अगर नंबर ऑफ वॉलंटियर्स आर 120 सीधे इस इक्वेशन में डालो.
हाँ,
1/10 इंटू एक्स कितना बोला मैंने? 120.
120.
राइट. प्लस 2 बोला. तो सेटिस्फैक्शन क्या हो गया? 14 हो गया.
14.
राइट. इसके ऊपर ऐसे आ जाए. तो ये प्रिडिक्शन कर रहे हैं. देखो अब इसको आपको पीएमआई के लिए इतनी जरूरत नहीं है. देखो पीएमआई के लिए सिर्फ इतना है कि एक्स एंड वाई का रिलेशन है. डायरेक्ट है तो ऐसा, इनडायरेक्ट है तो ऐसा, नो रिलेशन तो ऐसा. बट पता है इसको क्या बोलते हैं? मैं थोड़ा सा वो बताता हूँ. इसको इसकी लैंग्वेज क्या होती है? ये मशीन लर्निंग का पार्ट है. इसको हम बोलते हैं कि हमने क्या किया, डेटा को पहले ट्रेन किया. यहाँ ये डेटा जो है इसको बोलते हैं ट्रेनिंग डेटा. राइट. 100 तक का डेटा हमारे पास है. वी ट्रेन द डेटा, राइट, ऑन वी ट्रेन द डेटा एंड क्रिएट अ मॉडल. हमने इस मॉडल को ट्रेन किया. मॉडल क्या है हमारा? y is equal to 1/10x plus 2. अब उसके बाद इसको वेरीफाई कर सकते हैं और डेटा के साथ और हम प्रेडिक्शन के लिए यूज कर सकते हैं. इज दैट ओके? सो नाउ स्कैटर डायग्राम डिपिक्ट्स रिलेशनशिप बिटवीन टू वेरिएबल्स. अभी हम क्विज करेंगे तो उसमें क्वेश्चंस आएंगे. उसका एक क्वेश्चन आएगा स्कैटर डायग्राम को और आप आंसर कर लोगे. ठीक है. नाउ कैन वी प्रैक्टिस सम क्वेश्चंस ऑन क्वालिटी बिफोर वी वाइंड अप द ट्रेनिंग? क्वेश्चंस करें आप. Now, can you see my screen, guys?
Yes.
Yes.
The first one. Which of the following is not a part of quality?
Charlie.
Charlie, right? Values to sponsor. It's more to do with business case, right? So, can I say value to sponsor is not a part of quality? What should be the answer for second?
Control quality.
Bravo.
Yes, control quality. Why? The moment you see inspection, always put control quality. Absolutely right. What should be the answer for third?
Alpha.
What is this?
Alpha, I guess, Pankaj.
Okay. See, should it be Alpha or Bravo? Look at
Beta, bravo, bravo.
Bravo, right?
Programs to-
See, again, when you say
B Bravo.
Yes, yes,
Bravo,
yes,
because,
right,
right, because A is still a reviewing, right? So you're putting extra effort on testing, right? So
right.
now, fourth, we discussed a lot, right? You should be able to answer. Now, see, is it, first of all, is it quality assurance or quality control when you are doing audit?
Assurance.
Assurance, right? And it's a quality standard. So assurance is a
C.
part of managed quality, CHRD, right? CHRD, right? Now, what is just in time? You should be able to answer it. We've discussed just in time in reference to start to finish relationship. So it's
The
between
parts must be
Alpha,
delivered on
alpha.
time.
Alpha.
A.
A.
now, which of the following is not a part of quality management plan? Now, see, all of them except last one, a description of which deliverable don't have to be inspected. This is a part of scope statement. It's a kind of a exclusion. So if you say Alpha, Bravo, Charlie, all the three are part of quality management plan except this thing, right? Is that okay? Now you should be able to answer 7. We discussed just a few minutes before. Which of the following tools and techniques is used to show which categories of defects are more common?
B.
Pareto, right?
Yes.
Perfectly fine. Pareto. So I think you should be able to answer it. So tell me, what should be it? Again, inspection, then answer.
Control quality.
Control quality, right? Which tool or technique is used to break data into categories, right? किसमें categories में करते हैं हमने देखा था? Histogram में करते हैं ना categories.
Histogram.
Histogram में. When is inspection performed? When is inspection performed?
Anytime a project deliverable is produced.
Absolutely. Be proud. Yes. Now, what is the difference between control quality and validates? So, मैं थोड़ा सा बता देता हूँ. Control quality, you know, is an internal testing. Now, see, PMI uses the word validate scope. They do not use the word user acceptance testing. Validate scope actually means UAT, user acceptance testing, which is nothing but formal acceptance of the deliverables of the project. Right now, you can try.
D. Delta.
Right, delta. Okay. Perfect. Perfect delta. 12th. What should be the 12th?
Benchmark.
12th is benchmark. Perfect. What should be 13th? You are using a control chart to analyze defects. When something on the chart causes you to realize that you have a serious quality problem, what is the most likely reason for it?
Rule of 7.
Absolutely. Rule of 7, right? Rule of 7. Which of the following best describe the defect repair review? Now, again, I'll help you. First of all, now tell me one thing. If I see option D, review the repair defect to make sure it is within control limit. Now, so should it be control limit or should it be tolerance? When you review the repair defect to make sure it is should it be control limits or tolerance?
Tolerance.
Tolerance, right? देखो कंट्रोल लिमिट तो आपकी अपनी परफॉर्मेंस है, उसका वेरिएशन है +-3 सिग्मा, वो तो आपकी परफॉर्मेंस है, बट टॉलरेंस कस्टमर स्पेसिफाई करता है कितना वेरिएशन अलाउ है. बहुत मेनी टाइम्स पीपल आंसर इट रॉन्ग. डी नहीं होगा इसका आंसर, बिकॉज डी तब ठीक होता when the answer would have been review the repair defect to make sure it is within the tolerance. Then this would have been the answer. So this is incorrect. Now, don't you think C should be the answer? Reviewing the repair defect to make sure it is fixed properly. Or it is fixed. This means actually it is within the tolerance. Should it be Charlie or not? Tell me guys, should it be Charlie or not? Charlie होगा ना ये?
Yes, Charlie.
Now, what should be the 15th one?
D, statistical sampling.
Yes, statistical sampling. Because we are not testing everyone. Now, again, the same question. What is the difference between control quality and manage quality? Or manage quality can be treated as quality assurance, right? Same as, what is the difference between control quality and quality assurance? What should be the answer?
C.
C, right? Absolutely C, right? So C, Charlie. Now, which control quality tool is used to analyze process by visualizing, right? Graphically गलत हो गया यहाँ पे actually. Graphically नहीं होना चाहिए. By visualizing them maximum, right? So is it flowchart? When you talk about process analysis, is it flowchart or not? Right?
Yes.
Right? And there should not be any graphical. Now, 18th again. You are looking at a control chart to figure it out if the way you are using, right, you are doing your project fits into company standard. Which process are you using?
Manage quality.
Absolutely. It's a quality assurance, manage quality. Which of the following is Pareto, right? Now the last one, validated defect. Now see, validated defect repair will come after inspection only. So validated defect repair is output of which process? See, it's after testing only. So should it be called control quality or not? Should it be control quality?
Yes, yes.
Right?
Yes.
So, that completes our quality, right? And we are wrapping up today's session here. We'll catch up on Saturday again, right? Now, if in between, if in between you are available on any of the weekdays, right, before Saturday, right, let me know on the WhatsApp group. We'll try to have one more class, if you're okay with that. I am available morning also, and I can also adjust my plan, right? Early morning and late evenings are better for me as well, right? After 6 p.m.
Which topic, Pankaj?
Simple topics, very simple topics. See, we'll be doing very simple topics like, communication, stakeholder management, those topics, right? So, they are very easy and simple topics.
So is this some additional class?
No. It's a part of the course, right? The only thing is, we can do it little faster. So if you want to utilize one more day, see, you can give me any time before 9 a.m., right? Or after 6 p.m. or 7 p.m. better, right? So we can talk about this in the WhatsApp group, right? And we'll catch up next weekend for sure, right?
Okay. Otherwise, one more weekend.
Yes.
Okay.
Right. So we'll catch up next weekend, guys. Thank you. Have a great day to all of you.
Thank you.
Bye.
Thank you.